This video is a thought experiment. It can cause a small existential crisis. That is not a disclaimer for lawyers. It is a fair warning about what happens when you take general relativity seriously. When you stop treating a black hole as a hole in a cartoon and start treating it as a place where space and time obey rules that contradict the story your nervous system was built to tell. The thread holding everything together is a single question asked twice from two incompatible seats. What does falling in look like if you stay outside and watch? And what does it look like if you are the one falling? Physics. Two stories that cannot be stitched into one timeline without breaking. Once you feel that split, you will never hear the phrase event horizon the same way again. Black holes were not always called black holes. Karl Schwarzschild wrote the first exact solution to Einstein's field equations in 1916, months after general relativity was published, while serving on the Russian front in World War I. He died shortly after. His solution described a mass concentrated so strongly that light could not escape. For decades, many physicists hoped that nature would forbid such objects, that collapsing stars would shed enough mass, or that quantum effects would intervene. Roger Penrose showed in the 1960s that gravitational collapse can form trapped surfaces under general conditions. Observations caught up: X-ray binaries, quasars, the motion of stars at the galactic center, gravitational waves from stellar mass mergers, and finally, the shadow images. The thought experiment you are about to take is not fantasy bolted onto a fairy tale. It is the extreme limit of a theory that has passed every test we could throw at it, except the tests inside the horizon itself. Imagine you are on a research vessel in orbit near Sagittarius A star, the supermassive black hole at the center of the Milky Way, roughly 4 million times the mass of the Sun, about 26,000 light-years from Earth. We know it is a black hole, not because anyone has touched it, but because stars orbit it. The star S2 swings through space at thousands of kilometers per second on an elliptical path that only makes sense if several million solar masses are packed into a region smaller than the orbit of Mercury. That is how gravity announces a compact object when the object itself refuses to shine. In 2022, the Event Horizon Telescope collaboration published the first image of its shadow, a bright ring of radio light bent around a dark core, the size of a blueberry on the moon at that distance. The ring is not the event horizon drawn in ink. It is lensed emission from hot gas around the hole, with a diameter roughly 2.5 times larger than the horizon itself, because light paths bend. Even so, the image was a direct statement. Space-time is curved hard enough here that photons orbit and peel around a void. You are much closer than that telescope, close enough that the monster is not a press release. It is the dominant object in the sky, a silent weight around which stars have danced for billions of years. No of the crew, Marco, is listening to music at full volume through his suit speakers. No headphones. After polite requests fail, the rest of the crew decides, for science and for silence, to eject Marco toward the black hole. Cold? Yes. Physically instructive? Also yes. We are not endorsing crew justice. We are following the geometry. The scenario is absurd on purpose. Real missions near the galactic center do not exist. Human bodies cannot be casually dropped from 3 Schwarzschild radii next to a supermassive hole. We are compressing a graduate seminar into a story with a phone playing music, because stories are how most of us carry equations before we are ready to read the equations directly. Marco is a stand-in for any infalling probe, a bundle of atoms on a time-like geodesic. The phone is a clock and a light source. The crew is the distant observer chart. Strip the comedy and the skeleton is standard relativity homework made visceral. To make sure Marco actually falls in rather than entering a long elliptical orbit, you drop him from 3 times the Schwarzschild radius of the hole. That number sounds oddly specific. It is not arbitrary. The Schwarzschild radius is the distance from the center where, in Newtonian language, escape velocity equals the speed of light. About 12 million kilometers for this mass, roughly 1/10 of the distance from the Sun to Mercury. Inside 3 Schwarzschild radii, for a non-spinning black hole, there are no stable circular orbits. Astronauts in low Earth orbit stay up because they are moving fast sideways while gravity pulls down. Here, if you try to circle that close, Gravity wins unless you thrust outward constantly. The innermost stable circular orbit for a Schwarzschild hole sits at 3 Schwarzschild radii. Below that, you fall or you flee. There is also a photon sphere at 1.5 Schwarzschild radii, a shell where light can, in principle, orbit in circles. Marco is not dropped there. He is dropped outside the unstable orbit boundary. Then, given only an inward shove for a spinning Kerr black hole, the numbers shift slightly. Rotation drags space and can push the innermost stable orbit inward, but the lesson survives. Close enough to a supermassive hole, stable parking is impossible. You are choosing between engines and gravity. In the original framing of this scenario, the drop point sits about 44 million kilometers outward from the event horizon itself, on the order of the distance from Mercury to the Sun. Marco could still escape if we fired a rocket hard enough to remove that loophole. We strip him down to a spacesuit and a phone still blasting music. No propulsion, no rescue, only the equivalence principle waiting below. The fact that in freefall, gravity feels like weightlessness until the tidal gradient across your body grows large enough to hurt. Grab popcorn. We will run 2 analyses. First, what you see from the ship while Marco falls. Second, what you would see if the roles reversed and you were Marco. The same equations govern both. The incompatibility is not in the math. It is in which clock you trust. Between those 2 seats sits everything this video is about. Part 1 is observational astronomy with a human face. Redshift you can see, time you can measure on 2 devices, and image the Ds on approach. Part 2 is the interior odyssey. Disk, lensing, horizon crossing, Kerr rotation, inner horizon, cosmic archive, speculative endings. Do not merge them into one timeline in your head. The merge fails. That failure is the lesson. Einstein's general relativity is not a theory of forces pushing through space. It is a theory of geometry. Mass and energy tell space-time how to curve. Curved space-time tells matter how to move. Black holes are not objects with sharp surfaces in the everyday sense. They are regions where the geometry of time itself changes character. That is why the same fall can be finite for Marco and infinite for you. Without anyone lying, you are not watching the same time coordinate. The field equations look forbidding on a chalkboard. 10 coupled nonlinear partial differential equations in 4 dimensions with metric components that encode how intervals of spacetime are measured. You do not need the full notation to grasp the narrative. You need one insight. Free fall is geodesic motion, the straightest possible path in curved spacetime. Marco is not being pulled by a force in the Newtonian sense while he falls. He is following a geodesic. The ship, hovering or orbiting with engines firing, is not on a geodesic. That is why you feel acceleration on the deck while Marco floats in his suit until tides grow. The equivalence principle, Einstein's happiest thought, says acceleration and gravity are locally indistinguishable. Globally, they are not. The global difference is what creates horizons. Chart with the view from the ship. The first thing you notice is that Marco turns red. Do not mean sunburn from accretion disk radiation alone, though the environment near a galactic center is not gentle. Ray flares from Sagittarius A star have been observed when clumps of matter fall in, brief brightenings as gas compresses and heats. Human in open space near an active episode would face hard radiation even before tides matter. In our quieter baseline, the dominant color shift on Marco is gravitational redshift. Light leaving Marco must climb out of the black hole's gravitational well to reach your eyes. Climbing costs energy. Photon cannot slow down. It always travels at the speed of light in vacuum, so it pays by stretching its wavelength. Visible light slides toward red, then infrared, then microwaves, then radio, until your eyes and instruments lose it entirely. The effect has a precise cousin in spectroscopy. Astronomers measure gravitational redshift from the surfaces of white dwarfs and neutron stars. They measure it in the laboratory by comparing clocks at different heights on Earth. A prediction Einstein made, confirmed to exquisite precision. Near a black hole, the factor is not parts per billion. It becomes order 1. Then diverges in the coordinate time of distant observers as the horizon approaches. This is the same mechanism that makes the most distant galaxies look redder than nearby ones. Cosmic expansion stretches wavelength. Here, the stretch is gravity, not expansion. Watching a person fall toward a black hole is one of the few situations where you could, in principle, watch gravitational redshift happen in real time on a human scale. Enjoy the view. Sorry, Marco, there is a useful analogy that is not quite correct, but builds intuition before we break it. Imagine Marco shouting as he falls. You hear his voice deepen as he moves away. A Doppler shift because the sound waves arrive stretched. Gravitational redshift is not Doppler shift, though the two can be mixed in subtle ways when motion and gravity both contribute. Redshift here is primarily about the gravitational potential difference between emitter and receiver. Marco's atoms emit light at characteristic frequencies. You receive them with lower energy per photon because the light climbed a well. The universe is not expanding under his feet in this scenario. Gravity alone is doing the stretching. When you see distant quasars and galaxies redshifted, cosmology dominates. When you see Marco redden near Sagittarius A star, gravity dominates. Same symptom on the spectrum, shifted lines, different diagnosis. Astronomers separate them with models and geometry. You, on the ship, separate them with context. You know which well you are in. Now look at his phone screen. Still somehow playing music between the moment of release and your current ship time. Your clocks disagree. Suppose 10 minutes have passed on the vessel. Marco's phone might show only 8. Gravity does not only bend space, it bends time. Clocks deeper in the well tick slower relative to clocks farther out. The effect is small, far from the hole, and vicious near the horizon. You have used this effect without visiting a black hole. The Global Positioning System satellites orbit high enough that their clocks run faster than clocks on Earth's surface by about 38 microseconds per day from gravity alone. Plus a smaller correction from their speed. Engineers must subtract those microseconds or your car would miss its turn. Near Sagittarius A star, the gradient is not micro. It is macro. It is the whole show. Here is a clean way to say it. Proper time is what Marco's wrist and phone measure along his world line, the time he experiences. Coordinate time is what you synchronize across the ship and compare to distant beacons. Near a black hole, those two quantities diverge violently. The factor relating them goes to infinity at the horizon in the coordinates used by distant observers. That is why 8 minutes for him can be 10 for you now, and why later his seconds can stretch to your hours, then days, then lifetimes, without Marco feeling that his heartbeat has stopped. As Marco approaches the event horizon, the boundary near 12 million kilometers from the center, where escape velocity equals the speed of light, the redshift escalates. His image does not simply dim, it migrates out of the visible spectrum. He appears to fade, but he has not vanished in the sense of ceasing to exist. The light that used to arrive in colors your retina understands has been stretched beyond them. He is still falling. You are losing the carrier signal. There is a time scale for how fast the fading happens. For a stellar mass black hole, an infiler can redden and disappear from view in hundredths of a second as seen from a safe distance. For Sagittarius A star, the mass is larger and the gravitational gradient at the horizon is gentler in coordinate terms, but the qualitative sequence is identical: redder, dimmer, slower, frozen on the approach. The whole is patient. Your eyes are not. Some early 20th century astronomers discussed collapsed stars as frozen stars, objects so dense that light cannot escape, but that, from outside, never finish collapsing in finite time. Modern language prefers black hole because the horizon is a feature of the geometry, not merely a slowed collapse. The frozen image of Marco on the horizon rhymes with that old picture. The difference is that Marco's proper time does not care about your coordinate infinity. He is not waiting for your permission to cross. From the ship's reference frame, something stranger happens. Marco seems to slow, then slow more. Time on his phone crawls. He appears to freeze against the horizon, smeared and dimming, never quite crossing the line in any finite time you can wait. You will not see him pass through the event horizon. You will see his image linger and be on the surface like a stuck frame in a film, while in his own frame, he crosses in finite proper time and keeps going. If you tried to rescue him with a rope, ignore that the rope would snap and that tidal forces would shred any cable long before the horizon. you would discover another layer of absurdity. You cannot winch him back by pulling in coordinate time because his approach to the horizon slows in your clock. Signals you send downward redshift, signals he sends upward redshift. The rescue drama becomes a lesson in communication limits. The universe is not preventing rescue out of malice. It is enforcing a causal structure where the horizon is a one-way membrane for information from the inside out. Long before Marco is technically inside by his own watch, you might wonder whether anything ever truly falls in then. The astrophysically, yes, gas accretes. Stars are disrupted, matter crosses the horizon in finite proper time and increases the mass. The outside observer's infinite coordinate time is a label problem, not a conservation violation. The whole grow. The galaxy center knows how to eat. Marco is joining a process that has been running for millions of years. That is not a trick of bad cameras. It is coordinate time versus proper time. In the coordinates natural to distant observers, reaching the horizon takes infinite time. In the coordinates natural to Marco, the fall is finite. Both descriptions are correct. In general relativity, they are not reconcilable into one universal movie reel. That is the first crack in the treacher I want you to keep. The universe does not owe you a single shade now when gravity is this strong. Think about what never seeing him cross means. You might be tempted to say Marco never really falls in, that he hovers forever on the edge like a paused video game character. That is the wrong conclusion. Marco falls in finite proper time. If you could switch to his frame, if you could ride with him, you would not experience an eternal hover. The freeze is an artifact of your coordinates, the way lines of longitude all meet at the pole on a map. The pole is not a place where east stops working. The horizon is not a place where physics stops working. It is where your choice of global time label breaks. Meanwhile, the image you receive is also dimming and redshifting because each photon climbs a steeper well. Energy is not destroyed. It is deposited into the gravitational field in the accounting of the emitter and receiver. By the time Marco's last visible photons reach you, they may carry so little energy per quantum that your detectors cannot distinguish them from background noise. He fails because the messenger waves stretch, not because he stops existing on his side of the story. You are probably smiling now. Two thoughts arrive at once. First, the ship is quiet again. Second, you are very glad you are not Marco. Fair. So, for educational purposes only, nothing personal, we reverse the experiment. You are Marco now. Same as suit. Same phone. Same song which I have chosen for you because it is objectively perfect and you do not need to argue. Everything from here becomes more hypothetical. Not because the equations stop working, but because no experiment has returned a traveler from inside the horizon to settle the detail. The reversal is not cruelty for comedy. It is the only honest way to complete the lesson. The outside view is where human beings actually live. In orbit, on ships, on planets, receiving light signals. The inside view is where the metric says infallers go in finite proper time. If we stopped at Marco frozen on the horizon, you would leave with a half-truth that sounds like he never enters. Switching seats forces you to hold both films in one head. That is the cognitive work black holes demand. You are ejected. Head of you is Sagittarius, a star, and wrapped around it an accretion disk. Gas and dust spiraling inward, heated by friction and impacts until it glows. The disk is faint compared with quasi-monsters. Our galactic center black hole is stopping on a cosmic scale, accreting at a tiny fraction of its theoretical Eddington limit, radiating on the order of 10 to the 35th ergs per second in quiescent times. Enormous by human power standards, pathetic for a 4 million solar mass engine. Most of the matter swirling near the center never screams in X-rays the way Hollywood insists. It whispers. Still, you are now technically part of a plasma flow falling toward the hole. The disk is not a solid CD. It is a magnetized soup where friction, turbulence, and magnetic reconnection heat plasma to millions of degrees. Jets may launch along the spin axis in other systems. Here you are in the plane, where radiation fields can still cook a human. Your odds of radiation death are excellent. The black hole is almost the least of your immediate problems. Would end the video here, but the song is too good. So we imagine you survive the disk crossing. Luck, trajectory, shameless narrative immunity. Free fall, when tidal forces are small, feels like floating. The International Space Station astronauts are not beyond gravity. They are in free fall around Earth. You, falling towards Sagittarius A star, are in free fall too, until the difference in gravitational pull between your head and your feet becomes noticeable. For a supermassive hole, the difference is gentle for a long time. That is why cinema often misplaces spaghettification at the outer horizon for stellar mass black holes. Tides at the horizon can kill you before you cross. For Sagittarius A star, you can cross calmly and worry about stretch later. Look in any direction and the universe appears bent. Gravitational lensing wraps starlight around the hole. Single bright source can become arcs and copies. Einstein rings when the alignment is perfect, multiple images when it is not. The photon sphere at 1.5 Schwarzschild radii acts like a cosmic hole of mirrors. Light can orbit partway around the hole before escaping to your eyes. So you see the same star in several places at once, each image carrying a slightly different path history, and therefore a slightly different timestamp. Your stomach may object. Should have issued motion sickness patches at boarding. Too late. You are on an odyssey with no return ticket. This is not decoration. Lensing is how astronomers weigh galaxies and find dark matter. Here it is. Personal. The sky becomes a kaleidoscope because space-time is curved hard enough to steer light like glass steers a laser, except the glass is vacuum and the lens is mass. Einstein's general theory predicted deflection of starlight by the sun. Arthur Eddington's 1919 expedition made the effect famous. Here, the deflection is so strong that light can orbit partway around the hole before reaching you. You see multiple copies of the same constellation at different angles. Some photons have circled the hole once, others twice. Our image is a different path length, which means a different arrival time. A delay spread that would confuse your sense of simultaneity, even if your eyes could resolve the details. Falling into a black hole is not only falling in space, it is falling through a hole of mirrors where the mirrors are written into the metric itself. As you fall toward the horizon, the outside universe does the opposite of what your crew saw in you. Incoming light gains energy falling into the well. Wavelengths compress toward blue. Gravitational blue shift, the falling counterpart of redshift. Stars above you shift blue and bright, then ultraviolet, then X-ray in the extreme idealization. Meanwhile, your colleagues on the ship appear to live in fast forward. Their years can compress into your minutes. As the tidal time gradient steepens, darkness grows in front of you. Not because the universe ahead died, but because light from ahead must fight the geometry to reach your eyes, and most of the sky is now behind you, squeezed into a shrinking ring of blazing color. That ring is the last postcard from everything you will never touch again. It is the universe seen through a shrinking window as ingoing geodesics dominate your future. You are not falling into a tunnel in the ground. You are riding a world line whose future light cone is tilted so far inward that every allowed path leads deeper. The horizon is where outward is no longer a direction you can travel in space at the speed of light. That is the definition, not a wall. Tilt in causality. Light cone is the set of all directions light can travel from an event. In flat space, it is a neat 45-degree cone in diagrams. Near a black hole, it tips. Parts that used to point outward become inward. At the horizon, the cone lies tangent to the horizon itself. Inside, every future direction points toward decreasing radius in the Schwarzschild picture. That is why physicists say you cannot avoid the singularity in the non-rotating case. Not because a monster pulls you, but because every legal future is downstream. Causality becomes a one-way river. Your only choices are when, not if. In proper time, the blue shift of starlight as you fall is the price of looking up that river towards sources still sending light down. Photons you intercept have gained energy relative to infinity. Your instruments would record hard radiation long before your eyes enjoy the view. We keep the poetic blue ring because it is the correct sign of the effect, even if a real suit would be screaming dosimetry warnings. Then you cross the event horizon. For a supermassive black hole, the crossing can be surprisingly calm. Tidal forces at the horizon scale inversely with the square of mass for a given body size. Sagittarius A star is so massive that spaghettification, the differential stretch that pulls your feet harder than your head, is gentle at the boundary. You are not torn apart at the threshold. Stellar mass black hole would shred you earlier. Here you pass through infinite proper time with no fireworks required by the metric. Locally, you might not notice a marker. There is no painted line in space. The horizon is a global property, not a local fence you bump into. Something subtle happens anyway. The horizon is not a material wall. It is a one-way causal boundary. No signal you send outward after crossing can reach your friends. They were already losing your image. Now the loss is permanent. You could still receive signals from outside for a while if they are aimed inward. Another asymmetry that confuses beginners: communication with the ship is not symmetric. You can listen to a blue shifted past. You cannot call home. Below your feet, darkness. Not metaphorical darkness, the absence of returning photons from that direction. Light that fell in earlier cannot climb back to your eyes. In fact, light from your own feet and nose cannot reach your eyes either in the idealized picture. The geometry is so extreme that your body ceases to be a coherent visual object to yourself. You feel like two enormous eyes falling through void, which is poetic, and also a fair description of how strongly gravity can separate causal patches of your own body. That image, two eyes in the dark, is useful because it kills a persistent myth. People imagine the event horizon as a membrane you crash into, like a soap bubble made of force. Locally, space at the horizon is as smooth as space anywhere else in the vacuum solution. It would not slam into a floor. Tidal stresses might be small. The horizon is a global boundary in the causal structure, not a local wall. What changes is the set of directions your future can point downstream. All futures aim at the singularity in the Schwarzschild case, or at the richer Kerr interior in the rotating case. Your feet stop being visible because photons from them cannot follow geodesics that reach your eyes once you are deep enough. You are literally losing sight of yourself, one causal patch at a time. Look upward. If up still means anything, here is the surprise that confuses everyone on first contact. Light from the outside universe that fell in after you still moves at the speed of light relative to you. You can still see the cosmos you left, distorted, blue-shifted, compressed. Even after crossing the horizon, the universe does not wink out instantly. It shrinks and intensifies like a ring of fire receding above you. The black hole is not a tunnel with a door that slams. It is a region of space-time where all futures point inward. That lingering view is not a Hollywood cheat. It follows from the local constancy of the speed of light. Photons you catch are not forbidden because you crossed a line. They are on ingoing trajectories, compatible with your own. What changes is which directions can still reach the outside world. Becomes a window, not an exit. Down becomes the only long-term destination in the non-rotating picture. Your phone might still play music for a while, blue shifted into ultrasonic squeal, until hardware fails or tides when the crew cannot hear it. You can, if the hole were ideal, non-rotating, and you simply continued inward, tidal forces would eventually win. As you approach the singularity at the center, the curvature grows without bound. The stretch along your body becomes lethal. That is spaghettification in the Schwarzschild case. Not at the horizon for a hole this massive, but inevitably closer in. Tidal acceleration across a distance L scales roughly with the gravitational field gradient for a black hole of mass m. The tidal force between your head and feet, separated by about 2 meters, grows as you approach the singularity, like 1 over m cubed at the horizon, but blows up as you fall deeper. Because curvature increases without limit, Sagittarius A star's millions of solar masses buy you room. 10 solar mass stellar corps would not. Choose your black hole wisely if you insist on sightseeing in the Schwarzschild interior. The singularity is not a point in space waiting like a dartboard. It is a moment in your future. A space-like singularity you hit in finite proper time after crossing the horizon. You do not orbit it. You meet it the way you meet tomorrow. Rotation changes the singularity's character in the Kerr solution. It becomes more complicated. possibly ring-like in the ideal extension. But gentleness is not on offer forever. Fortunately for the story, not fortunately for you. Sagittarius A star spins. Real astrophysical black holes are described by the Kerr solution found by Roy Kerr in 1963, a rotating metric with an inner structure far richer than the cartoon one-way pit. Rotation drags spacetime itself. Frame dragging, also called the lens-stirring effect. If you tried to stand still relative to distant stars near a spinning hole, you would feel yourself pulled around. Space is not a passive stage. It participates. The outer event horizon is where the outward-pointing light cones tip over and inward motion becomes mandatory. The inner horizon, the Cauchy horizon, is a second surface inside the Kerr geometry, where the roles of ingoing and outgoing coordinates exchange character in the ideal math. It is not a second exit, it is a second threshold with almost opposite flavor from the outer event horizon. Penrose diagrams, conformal maps that compress infinite spacetime onto a finite drawing, show the interior as a diamond-shaped patch bounded by two horizons and a singularity. Students meet them in graduate courses, fallers meet them in proper time. If the interior is as smooth as the equations suggest near the outer horizon, infalling things are trapped near the inner horizon. In the ideal Kerr picture, ingoing and outgoing modes pile up. Radiation and matter that fell in over millions of years can blue shift without bound as they approach the Cauchy horizon. An instability studied since Roger Penrose flagged infinite blue shift there, and since Eric Poisson and Werner Israel showed mass inflation can blow up curvature in charged and rotating holes. In realistic accreting black holes, that inner region is probably not a stable tourist lounge. Modern calculations by groups studying astronomically realistic interiors suggest accretion feeds energy into perturbations that may trigger space-like collapse, a violent singularity, before a traveler could cruise through a calm inner passage. The video still walks the ideal version, because that is where the human imagination goes when it asks what the interior is for. And because the original scenario you are following was built on that Kerr interior story. In the thought experiment, as you continue inward, the rotating spacetime generates an effective repulsion from frame dragging that can balance inward gravity at the inner horizon. Cross it in the simplified story, and you are flung outward again. Not out of the black hole, never out of the black hole, but away from the central singularity. Still inside the trapped region, do not hope yet. Outward here means toward the inner horizon shell, not toward home. This bounce is the Kerr interior's most seductive feature, and probably its most misleading. The inner horizon looks like a second chance, a repulsive barrier that sends you back before you hit the crushing center. In the polished narrative, centrifugal support from dragged spacetime fights gravity at the Cauchy horizon, the way rotation fights collapse in a spinning star. But you remain inside the outer trap. There is no trajectory that returns you to the ship's coordinate patch. You are rearranging your fall inside a prison whose walls are causal, not metallic. And because the repulsion in the ideal story comes from space-time moving, in the extreme frame dragging so violent that ingoing light cannot progress the way you expect, you are not being thrown by a force in the Newtonian sense. You are being carried by the geometry itself. The inner horizon is where the universe's rotation becomes a physical conveyor belt. You cannot step off, because ingoing radiation cannot pass outward through that inner horizon cleanly. In the idealized geometry, modes bounce and accumulate. Light and information stack in a region around it. As you approach, you meet not only your own fate, but the compressed history of everything that ever fell in before you. Every photon trapped since the black hole formed carries a story. The first stars igniting when the cosmos was young, the assembly of the Milky Way from merging protogalaxies, the generations of supernovae seeding heavy elements, the sun's birth in a spiral arm, Earth's accretion, and the late heavy bombardment. Universal time capsule, viewed from the worst seat in the house, with no pause button and no exit. The idea is not that you could comfortably binge-watch cosmic history like Netflix. The blue shift and energy density would be lethal in the realistic mass inflation picture. In the idealized story, the point is structural. The interior of a rotating black hole is a place where light cones fold and history piles up along surfaces that are not supposed to behave like friendly walls. Information falls in, information sticks. The universe keeps a scrapbook on its own terms, not yours. Roger Penrose's cosmic censorship conjecture, still unproven in full generality, says nature hides singularities behind horizons, so we do not see naked pathology in the outside universe. You, inside, are the one who gets the unfiltered encounter. The inner horizon pileup is cosmic censorship failing in a different direction, not hiding the singularity from you, but hiding you from ever reporting back. The archive of light is real in the geometry and unreadable to colleagues on the ship. It is the most extreme closed diary in physics. The original Portuguese script mentioned a video about this same topic made years earlier. Passing through the horizon as part of the information stream, that is not vanity inserted into physics, it is the logical endpoint of the thought experiment. If all infalling signals persist in the interior geometry, then every lecture, every song on Marco's phone, every careless radio leak from Earth is part of the material that could, in principle, be encountered inside, scrambled, blue-shifted, and unread without a receiver that no engineer on the ship can build. Then the rotation-driven bounce sends you outward again in the interior geometry. You intersect not only the past light pile, but in the extreme time dilation regime, the future infall of everything that will ever cross the horizon after you. Your proper time is short, the outside universe is fast. Seconds for you can be millions of years out there. This is where the original video's most dizzying claim lies, and it deserves to be stated carefully. Extreme time dilation near the inner horizon can make the rate of change of the outside universe, as encoded in infalling light, appear compressed into brief proper time intervals for you. You are not literally watching Earth's continents drift in real time like a sped-up documentary, unless the geometry and blue shift conspire to deliver that information in a coherent image, which the unstable realistic interior probably forbids. In the thought experiment, the poetic truth is structural. The black hole interior couples your wristwatch to cosmic history. Past infall and future infall become layers you may encounter along your world line, because light cones have folded and the distinction between yesterday's infall and tomorrow's infall is no longer the tidy separation familiar in flat space. You could watch the sun's future, its red giant phase swallowing inner planets, its white dwarf remnant cooling, the Milky Way's future mergers, supernova rates rising and falling, the formation and dissolution of civilizations you will never name, the slow chemistry of life persisting or failing on countless worlds, and eventually the long twilight of stellar formation as the cosmos exhausts its usable gas. You could watch Earth-specific futures only as part of that wider blaze, continents reshaped, climates rewritten, species replaced, the possibility of spacefaring descendants who might one day argue about black holes exactly as you did before the fall. The original script mentioned colonization of space and the eventual extinction of all life in the universe, not as guaranteed prophecy, but as the kind of epoch you might infer if future light from the outside were readable to you at all. That is the vertigo. A human lifetime of falling could, in principle, overlap with the thermal and stellar death of the cosmos in the received signal. While your own aging remains minutes, you could watch the universe's matter dilute in accelerated expansion, stars wink out, and on timescales so long they dwarf human history. The black hole's own Hawking evaporation, when quantum effects allow the horizon to leak and shrink. For Sagittarius A star, that evaporation time is on the order of 10 to the 67th years. The number is so large, it is not a schedule. It is a reminder that even black holes are not eternal in quantum theory. They are slow prisoners, not permanent gods. When evaporation finally wins in the far future, the hole shrinks and eventually pops in a quantum flash. but not on any calendar that matters to Marco's phone battery. Gravity pulls you back toward the inner horizon and the center. What happens after that is not settled. Speculative branches multiply. Perhaps you are expelled through a white hole into a newborn universe. A baby cosmos on the other side of a mathematical extension of the Schwarzschild geometry. Height holes are the time-reversed twin of black holes on paper. Things can fall out, but not in. Whether nature produces them as anything more than an equation is unknown. Some cosmological models flirt with the idea that the Big Bang had white hole-like traits. That is not the same as saying you survive Sagittarius A star by popping out elsewhere. Perhaps the interior connects to an Einstein-Rosen bridge, a wormhole throat that might link distant regions in the equations, but is almost certainly not a practical subway for astronauts. Traversable wormholes need exotic matter with negative energy density to keep the throat open. Without that, the bridge pinches off faster than light can cross. Science fiction loves the shortcut. General relativity allows the sketch. Nature has not issued building permits. Perhaps the inner horizon radiates so fiercely in the real, unstable version that you were vaporized long ago, your atoms joining the hot plasma of the disk, your remains evaporating with the hole on timescales no human calendar will ever reach. Perhaps firewall scenarios from the information paradox, ideas that the horizon is not smooth, but a violent membrane that disintegrates in falling matter to preserve unitarity, would have killed you at the outer horizon in ways the classical story skips. Perhaps you hit a space-like singularity and cease, with no meaningful continuation of your world line. The honest answer is, we do not know. The secrets are behind the event horizon, not because nature loves drama, but because no signal returns. Everything past that surface is extrapolation from equations tested only in the weak field limit. GPS satellites, Mercury's orbit, gravitational waves from merging stellar black holes detected by LIGO and Virgo, the shadow of Sagittarius A star. The interior is controlled by gravity and quantum theory together, and we do not yet have a complete map of that marriage. That uncertainty is itself the trade show. Black holes are where our two best theories are forced into the same room. General relativity says Marco crosses in finite time. General relativity also says you never see him cross. Quantum mechanics says black holes radiate and may encode information on the horizon in ways we are still arguing about. The black hole information paradox posed sharply when Stephen Hawking showed in 1974 that black holes emit thermal radiation and slowly lose mass. If the radiation is perfectly thermal, it carries no memory of what fell in. That violates quantum unitarity, the principle that information is never destroyed, only scrambled. Physicists have spent decades trying to reconcile a smooth horizon with a quantum bookkeeping that balances. Holographic proposals, inspired by work on black hole thermodynamics and sharpened in string-theoretic contexts, suggest the horizon might encode information on a two-dimensional surface in a way we do not yet fully understand. For astrophysical holes, firewall proposals push the other direction. Maybe the horizon is not smooth for an infouler after all. None of that rescues Marco's phone signal. It reframes what the horizon might be made of. The trade show is not choose your favorite interpretation. The trade show is the place where gravity becomes absolute still, has open homework at the foundation of physics. Black holes have entropy. Einstein and Hawking showed the area of the horizon measures the number of microstates, a staggering entropy for Sagittarius A star on the order of 10 to the 91 in natural units. That connects thermodynamics to geometry. It connects information to area. It is also why the information paradox hurts. If the whole radiates away and disappears, where did the bookkeeping go? Did the information leak out in subtle correlations in Hawking radiation? Is it stored on the horizon until the end? Is it copied and burned at a firewall? These are not details for philosophers in armchairs. Many, 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 many. Nowers, they are the quantum completion of the same object. You just watched redden and freeze. LIGO and Virgo have heard smaller black holes collide. Stellar corpses merging, ringing space-time like a bell, emitting gravitational waves that carried energy and angular momentum away. Those detections confirmed horizons in the sense that the ringdown matched general relativity's predictions for merging compact objects. Sagittarius A star is quieter on human timescales, but star orbits and the event horizon image already anchor it in the same family. The thought experiment is an extrapolation along a curve we have measured at the shore. Return to the ship. Quiet at last. Marco is a fading red smear on the sky that will never complete its crossing in your lifetime, somewhere in the metric, not in your shared experience. He has already passed the point of no return and is living the second half of the story we can only narrate, not verify. 2 clock, 2 films, the whole. The thread we followed from the beginning was never only spectacle. It was the split between proper time and coordinate time, between what you feel on your skin and what the distant universe can ever record. Every other effect, redshift, blue shift, freezing, lensing, the inner horizon archive, Hawking's slow leak, hangs on that split. Black holes are not scary because they are dark, they are scary because they expose that time is not a single global clock you and Marco share. It is a local instrument stitched together only where gravity is weak enough to pretend otherwise. Walk the thread one more time as a checklist, because long scripts deserve a spine you can feel at the end. Marco is ejected from 3 Schwarzschild radii, so geometry guarantees in full. You watch him redden, because photons climb out of a well. You watch his clock log, because time runs slower deep in the field. You watch him freeze on the horizon, because your coordinate time never reaches the crossing. He crosses anyway in his proper time. You become him and see the disk, the lensed sky, the blue shifted ring, the calm horizon crossing for a supermassive hole, darkness below, universe above, then the care interior with frame dragging, inner horizon bounce, piled light from cosmic history, extreme mixing of outside time, speculative endings, and honest ignorance. None of the steps are optional ornament. Arc is the answer to a question the previous step forced. What should stay in your head when the details blur is smaller than the full list, but heavier than a factoid. 2 observers can both be right about the same fall and still never agree on what already happened. That is not social misunderstanding. It is physics at the edge of causality. The black hole is the place where the universe stops being a shared calendar. If there is a moral, it is smaller than the physics and more practical than Hawking radiation. On a long research voyage, wear headphones. The universe is loud enough without you adding a soundtrack to someone else's fall. And if you ever stand near Sagittarius A star for real, which you will not, but if remember that the person falling beside you may already be deep inside while you still watch them glow on the edge, forever almost there, forever gone. Ne'er last pressure on the threshold, because you deserve to leave with something that bites. Everyday life trains you to believe in a shared present. We argue about the past, we bet on the future, but we'll assume now is a negotiable meeting point. Black holes are a machine for proving that assumption false under strong curvature. Marco's now and your now are not the same foliation of space-time. The horizon is where that disagreement becomes permanent. You will age. His phone will tick 8 minutes while you count 10. Later, you will count years. While his image hovers, he will cross and fall toward an inner structure you can describe only with equations and stories. Both of you are real. Both clocks are real. The universe does not pick a single winner. It picks geometry. That is the existential crisis advertised at the start. Not that you are small, which you already knew, but that simultaneity is a luxury gravity can revoke. Keep the headphone, keep the respect for horizons, and keep the thread. What you see and what you feel can be 2 true films of one fall, never spliced into one.